We are still on our series on how to solve financial maths question, and this is part 4. And again, let's remember financial maths. What is the question we are asking ourselves? The situation presented, is it a once-off payment, therefore compound formula? Is it conversion, meaning year to for interest rate, like 1 year equal 12 months, or is it many payments? And at this stage, we understand many payments, that is the most complex. And here we have the formula that will always work in all situations is the sum formula, sum in geometric sequence, or amortization formula that only work in a specific situation. First has to be the end period, and it will have to go from situation of having a debt, from not having money, from having money, the loan kind of is not really your money, but anyway, to having zero money. Okay, so let's have a look at this specific example so that we can apply our formula. So here we have a sum of money A is invested in a fund and it is withdrawn after T years when T belongs to N. So what happened? A specific amount of money is invested. How long is there? For some years. Then we are given what? An interest rate. Now, so is it conversion or is it about payment? Well, it's not a conversion. I have the interest rate, so I'm not doing that. This is about payment, and it is a once-off payment, isn't it? Because that amount of money is invested and it's there. We are not adding to it. We are not doing every month, every year. Just once-off payment. That's it. So that means we're going to be dealing with our compound interest formula. So let's therefore focus on here. What are we going to fill in place of F, P, I, and T? Now, A is what? The principal money, the present money, the money that is invested. So that will be my A. Then we have what? T years. So that's just T here for T because we don't have. And then the money is invested at a fixed rate of, so we have at least interest rate. So 0.0675. That's our interest rate. Find the least value of T. So T I'm looking for. So I understand that's the one I'm looking for. And then we are told so that the investment will amount to more than 2A when it is withdrawn. So what is that in our formula? So that's that F value, 2A. So what I'm looking for here is the T. So that means 2A will equal A multiply 1 plus the interest rate 0.675 to the power of T. And when I'm looking for the power, I know I'm going to be using logs, isn't it? Okay, let's have a look at next part. So here we have Olga. Olga puts 3,000 into saving account. Interest is added yearly, and we have to see how much she has after 5 years. So it's not about conversion. We have the interest. So payment is a once-off, isn't it? Because she puts the 3,000, doesn't add. It stayed there for a specific period of time. So we know that's going to be our compound interest formula. So again, let's identify our elements. So P is her investment, her present value, interest rate 0.024. The time is 5 years, and F is the one we are looking for here, really straightforward. In the next part, Chen puts a different amount in saving accounts, the same interest rate, and then after 6 years, he has 4,000. Work out how much money he put into the account. So here again, we have that once-off payment, not conversion, not monthly. So we know again that is our compound compound interest formula. So this time, what do we know? We don't know how much he invests. We know that F will be 4,000. The interest rate is the same, 0.024. And the only thing as well, the difference is the period of 6 years instead of 5. Sub that in and solve it. And then the next part, Fiona is taking out loan at the same annual interest rate. Fiona makes quarterly payment and therefore work out quarterly interest rate that is equivalent to yearly. So here we know this is the conversion part when 1 plus I to the power of t equal 1 plus I to the power of t. And here we are comparing 1 year with 4 quarters, isn't it, that are in the year. So here we have to, what we have to watch out for is, well, what values are we feeding in into our formula. So we know time is 1 year. We have the yearly interest, so 0.024. The interest I'm looking for is quarterly, so the other I, and then t will be 4 here.